Hi everyone, thanks so much for tuning in to this presentation by Air Products Membrane Solutions. My name is Kyla Dewey and I'm a product line manager for non-atmospheric gases, notably for biogas upgrading to biomethane, also known as renewable natural gas. We, as Air Products Membrane Solutions, provide separation equipment and help to optimize your designs with the use of our biogas upgrading membrane modules. So today I'm going to talk to you about biogas upgrading cycle options that we have available, as well as give you just a brief overview of Air Products. So, why choose Air Products? One of the benefits to you is that Air Products has a lot of experience in industry, and we own and operate many of our own facilities. We do over $12 billion in sales, have been in business for over 8 decades, have over 750 production facilities, and serve over 250,000 customers. Safety is really at the center of everything that we do here at Air Products. Maintaining a safe workplace is truly a fundamental and moral responsibility, and we take the approach that all accidents are preventable, and the only acceptable goal is 0 incidents every day in each of our locations. So specifically in Air Products Membrane Solutions, we do have a global presence. Our Membrane Solutions headquarters is located in St. Louis, Missouri, and we do have 2 other global offices, one in Norway and one in China. Also, Air Products corporate headquarters is located in Allentown, Pennsylvania in the US. We have over 270 references in biogas upgrading and have a variety of other references and experience in process gases, engineered to order systems, and marine nitrogen membrane systems. There's a lot of information on this slide, but it really goes into how our membrane modules work. So you can see in the first picture on the left, all of those fibers that are enclosed inside of our shell and casing. The middle picture shows these fibers on a more microscopic level where you can really see that it's a hollow polymer fiber. And when the compressed gas mixtures enter the separator, fast gases, in the case of biogas, this is carbon dioxide, are able to travel easily through this fiber and permeate through the sides and exit out the side port. Slow gases, such as methane, don't permeate through the fiber and continue through the length and exit out the end of the separator. And you can see this in the last couple pictures on the fiber level and with the diagram of our separator. So one of the things that really sets Air Products Membrane Solutions apart is that we have a stellar applications engineering team. They will really work with you to find whatever solution you're looking for, whether that's optimizing operational costs, optimizing capital costs. They're willing and flexible to work with you on your next project. So I'm going to talk through the different options that we have in terms of 2, 3, and 4-stage system designs. 2-stage systems are very ideal for compact, low-cost, simple projects. They're really made for applications that are able to accept 93 to 97% methane recovery. Now, this doesn't work for everybody, but if it works for you, this is an ideal way to save on those capital costs if you don't truly need a 3-stage system. And if you think that you may need higher methane recovery in the future, you can always plan to add a 3rd stage when you're ready for that. So here I'll walk you through a case study where we have a constant raw biogas feed of 60 mole% methane and 40 mole% carbon dioxide with an operating temperature of 20 degrees Celsius and an inlet pressure of 16 bar gauge. Now, we can take a look at varying methane recoveries and purities in a two-stage system to compare relative membrane quantity and power consumption. So, taking a look at this light green column, we're assuming that the base case is 97% methane recovery and 99% purity. If you're able to lax a bit on the purity, you can see that you do save on the number of membranes that you need, and you do save a little bit on power consumption as well. If you increase the methane recovery and keep 99% purity, your membrane count will go up, as well as your power consumption, but it's the same trend in the last column that if you're able to bring your purity down to 98%, you do have savings both in capital costs and operational costs. Next, we'll look at three-stage systems. These are a very versatile design where you can add different equipment in to potentially change the outcome of your design for capital and operational costs. This is really ideal for situations where 98 to 99.5% methane recovery is needed. Here in this case study, we're going to keep the same raw biogas feed at the same temperature and pressure, but we're also going to keep recovery constant at 99.5% methane and product purity constant at 98.75 mole% methane, which is very typical. Here we'll compare a basic three-stage design in the light green column to a couple different equipment variations. So if you're able to put a vacuum pump on the vent, you will have savings in your membrane quantity and in your power consumption. And if instead you add an interstage blower to your three-stage system, you see a significant decrease in relative membrane quantity, as well as a bit of power consumption savings. Last, we're going to look at four-stage systems. So here, it's very ideal for situations where you want high methane recovery, over 99.5%. And you can configure this with one compressor or two compressors, which is why you can see the second compressor has a dashed line around it in this diagram. And Air Products Membrane Solutions has specialized separators for four-stage designs, as well as proprietary cycle designs. So in our final case study, we'll look at the same raw biogas feed at the same temperature, this time with a higher recovery of 99.8% methane and the same purity as the three-stage example. When comparing these four-stage designs to a three-stage, you can see that when you use one compressor at the same pressure as a three-stage, you do have an increase in membrane quantity. But if you are able to increase your pressure slightly to 16 bar gauge, you will get an equivalency in relative membrane quantity and power consumption to a three-stage design. And if operational costs are what concerns you the most, adding two compressors to this design will leave you with a bit of a higher capital cost investment on the front end, but will give you significant operational savings over the life of the asset. That's all I had time for today. Thank you so much for your time, and please reach out if you had any questions on today's presentation or if you would like to work with us on your next project. Thank you again.